Welcome back to MA 1103 Business Mathematics. I am Renovia Simanjuntak, and today we will learn about the graph of a function from chapter 1.2. Okay, so before we learn how to draw a graph of a function, we will use what we call the rectangular coordinate system. So here we have a plane, and then we divide the plane by using two lines, one horizontal and one vertical. So the horizontal line we call horizontal axis or x-axis because we usually represent that axis with variable x, which is usually an element of the domain of a function. Okay, and then we also have a vertical axis, which we call also the y-axis, because it's usually representing the values of variable y. All right, so that's the rectangular coordinate system. And then in this coordinate system, we will draw a graph of a function, which is another way to represent a function. Remember, previously we have learned two ways to represent a function. First, by using equation, and the second is by using tabular data. So this is another way to represent a function. So what is a graph of function? Graph of function is just points, collection of points, where the points will be in term of x comma y, where x is in the domain and y is in the range of the function. Okay, so here we have the point of in the form of x comma y or x comma fx, and we collect all these points and we will get the graph of a function. So how do we draw a graph of a function? In this subchapter, we will learn the simplest way to draw a graph of a function just by plotting all the, not all, but some of the points, maybe some important points, and then we try to connect them all. Later on, of course, we will learn how to draw a graph of a function in a more sophisticated way. Okay, let's see this example. Minus x squared plus x plus 2. This is the function f. And then we try to find out what is the value of sum of the x, sum of the elements in the domain. So we here choose how many? 1, 2, 3, 4, 5, 6, 7, 8 points. Okay, so if it is minus 3, it will be minus 10. If it is minus 2, we put into the function, it will be minus 4. This one will be 0. This one will be 2. This one will be another 2. Is it correct? Yeah, correct. This one will be 0. This one will be minus 4. And this one will be minus 10. Okay, so we have count some of the points, and then now we try to plot them in the rectangular coordinate system. So the first one is minus 3, minus 10. So this is minus 3 minus 10 here. And then we have minus 2 minus 4. And then we have minus 1 0. Another one is 0 2. And then 1 2. And then 2 0. And then 3 is minus 4 here. Okay, and then we can sketch the graph of function. It's not really drawing, by connecting all of these points. So for example here, Try to connect. This is not very good, but you can try to draw it better than me, okay? All right, so this is a sketch of a graph, of the graph of the function that we have before, okay? So, like I said before, sometimes there are important points that we can include in the list of points to sketch the graph, right? So here are some of the important points, yeah. What we call the intercepts, yeah. There are two kinds of intercepts. The first one is x-intercept and the second one is y-intercept. Okay, so what does it mean, x-intercepts? Those are the points where a graph crosses the x-axis. Yeah, so that's why it's called the x-intercept, because they are intercepting the x-axis. Okay, how to find it? How to find x-intercepts? We set y equal to 0. Yeah, why is it y equal to 0? Of course, because when a point intercepting the x-axis, of course, the value of the y will be 0. Yeah, so we set y equal to 0 and solve for x. And the second one is for y-intercept. We have a point where the graph crosses the y-axis. So now, when the graph crosses the y-axis, okay? So of course, it happens when x is equal to 0. Yeah, so we only find what is the value of f0. And remember, f is a function, and so f0 should be only one values. If there is a values there, yeah, should be at most one values, yeah. So that's why in the definition of y-intercept here, we can see here that we can only have a point there. Okay. What about in the example that we have before? Yeah, do we have x-intercept and y-intercept? Yes, we do have. We have x-intercept, which is here we have -1, 0 and 2, 0. These are the x-intercept, and we also have y-intercept, which is 0, 2. Yeah. Yeah. Okay. So you can see here in these two types of intercepts, finding y-intercept is not that difficult, yeah, because we just have to substitute x equal to 0 to find the y-intercept. But for finding x-intercept, sometimes it is not that easy. All right, so now if we have a graph, how can we detect that that graph is actually representing a function? Yeah, so one of the way that we can use is the vertical line test. Yeah, so in this vertical line test, we use this following property, which is a curve is a graph of function if and only if no vertical line intersects the curve more than once. Okay, why is that? So let's see this example. If you see the figure on the right, if we take vertical lines here, yeah, if we take vertical lines, and you can see there are two intersections, yeah, that means for one value of x, there are two values of y, right? So in that case, this is not a graph of a function, yeah, because one value of x have two values of y, yeah. But in the right hand side, you can see anywhere you take vertical line, the intersection will be only in one point. So the one in the left is a graph of a function. Yeah, so vertical line test will give you easily when a graph is representing a function or not. All right, so there are some important graph that you will find uh, frequently in the future lectures. Yeah, so here is one of them, which is called we call parabola. So parabola is the graph of this function. Yeah, ax squared plus bx plus c, where a is not equal to 0. Yeah, when a is equal to 0, then it is not a parabola. Okay, so why do we call it a parabola? Because it has what we call a U shape. Yeah, and the U shape will opens up if a is greater than 0 and opens down if a is less than 0. So what does it mean opens up? Opens up looks like the figure on the left here. Yeah, this is opens up and this one opens down. Okay, so here if we have a parabola which opens up or down, then we have the peak. Yeah, here we have the peak, and we have sometimes we have a valley. Yeah, so this one is the valley. Yeah, so this kind of point, the peak or the valley, we call the vertex of the parabola, and it always occurs when x is equal to minus b over 2a. Yeah, x is equal to minus b over 2a. Okay, why is that? We will actually find why the vertex always occur here when we already learn about derivative. Yeah, so it will be in the later chapter. Okay, but for now, let's believe that this is true. Okay, so minus b over 2a. Okay, let's see one example connecting to parabola. So we have a manufacturer producing a particular commodity. So when X hundred units of those commodity are produced, they can be sold for a unit price with that function. Yeah. Okay, so the question is, at what level of production is revenue maximized? Okay, so to answer this question, of course, we have to know what is the revenue function. So remember, the revenue function is the number of unit being produced, which is X times the unit price. Okay. Yep. And then this is going to be X times 60 minus X, and is equal to 60X minus X squared. So remember, this is a parabola. Okay, so you remember the general form of the equation for a parabola, which is ax squared plus bx plus c. So what is the a here? The a is the coefficient of x squared, which is minus 1, and b is the coefficient of x, which is 60, and c, we don't have a c here, so c is equal to 0. Yeah, and remember, the parabola opens up when a is positive and opens down when a is negative. So here we have a parabola which is opens down. And when a parabola is opens down, it has a peak. So its vertex is a peak. So that's why we have a maximum revenue. Yeah, because we have a peak. All right. So the question is, at what level of production the revenue is maximized? So we want to know in which point the fat tax occur. Yeah, and we know the fat tax occur when x is equal to minus b over 2a. Okay, so what is x here? What is the minus b? Minus b is minus 60 over 2a is minus 2, and we have 30 here. Yeah, so the revenue is maximized when we have 30 here, but remember the unit here is 100, yeah, 100 units. So we have here when 3000, yeah, 30 plus 100, 3000 units are produced, yeah. Okay. Right, so that's the answer. And the next question is, what is the maximum revenue? So this is when the revenue is maximized, and then now we want to know what is the revenue. Yeah, so the revenue will be R of 30, which is just what, 60 times 30 minus 30 square, which is what, 1000 minus 900, so this is 900. But again, this is in 100, yeah, x is in 100, so we have the maximum revenue another 0, 0. Yeah, so $90,000. This is the maximum revenue of this manufacturer. All right. Okay, so that is one of the important graph that we have, which is parabola. But then we have another one. Yeah, not another one. There are some more. Yeah, there are 3 more. Yeah, so we have power, polynomial, and rational functions. The first one is a power function. So it's a function of the form of this one, yeah, x to the power of n. So that's, we use power, that's why it's called a power function. And then the second one is the polynomial function, and you can see here that the function represented by a parabola is also a polynomial function. Yeah, so this is an x to the power of n, an minus 1 x to the power of n minus 1, and so on. Yeah, and you can see if n is equal to 2 here, we will get the function of a parabola. All right. Okay, so when an is not equal to 0, then n is called degree. Yeah, so for example, if we have here px is equal to for example x plus 1, then the degree of this polynomial is 3. Yeah, so we see the largest power when the coefficient is not 0. Yeah. Okay, all right, and the last one is what we call rational function. So there's just a quotient of 2 polynomials. Yeah, we have 2 polynomials p and q, and then we take a quotient of those 2 polynomials. So that's the rational function. So this is some example of rational function. Yeah, so we have 1 over x squared. So this is polynomial of degree 0, polynomial of degree 2. Yeah, quotient of those 2 polynomials. This is quotient of 2 polynomials of degree 1. And the last one is a quotient of polynomial of degree 1 and degree 2. Yeah, so these are two examples. This looks complicated and difficult to draw the graph, but we will learn how to draw this kind of graphs later on, yeah, in future chapters. All right, so the last one in this subchapter is about intersection of graphs. Why do we need to find intersection of graphs? Because sometimes we need to determine when two functions are equal, yeah? And when two functions are equal, it means they will intersect at a point, yeah? Because they have the same values, yeah? For the same x, they have the same y, and they will intersect. Okay, so this kind of problem, you will find it frequently uh, in the following lectures, yeah. So this is one of the example, yeah. If you want to see where the demand will be equal to supply, yeah. So you have a demand function. Here you have a demand function, and you will have a supply function, and you want to know where those demand equal to supply, and you have to find intersection of a graph, yeah. So how do you find it? You just have to take equality of these two functions, yeah. So for example, here we have the demand function is 174 minus 6x, and you have to make it equal to the supply function, which is x squared plus 14, yeah. And then of course, to find the points when this occur, you have to solve this equation, yeah. So you have here x squared plus 6x minus 160 equal to 0. And how do you solve this equation? Of course, you have learned it at high school. You just have to factorize, yeah, this degree 2 polynomial, and then you find the solution. Okay, so you can try this at home, yeah. You can try to find the solution of this. Okay, so that's the end of this subchapter, and what you have learned here is a graph, and then you can decide when a graph will represent a function by using the vertical line test. And then how to draw a graph. You just find some of the points of the function, yeah, and some points are more important than the others, yeah. So some important points are the intercepts, and then we also have some special graphs. We learn about those, which is the parabola, power, polynomial, and rational functions, and then we also learn about intersection of graphs. Okay, that's it for subchapter 1.2, and I'll see you again in the next video. Have a good day.